Hello, hello, discrete math students. Sorry about that. My my dog is loud and likes to bark, so we're just gonna have to make the best of it. I haven't made a video for you guys in quite a while. It's been about a week, so let me work on a few problems. As usual, I don't want the video to become extremely long. There are lots of reasons for that. One of the most practical reasons is that most students have a limited attention span, and if you're watching a video that's more than an hour long, you are probably going to lose interest pretty fast. So that's why I try to keep these videos under an hour if possible. Is that always possible? No, but as much as possible, I try to keep the videos under an hour. And also, I'm recording these videos from my own house. And sometimes this is a very noisy house. this is not this is not a professional environment. It is a residential environment. It's a private residence. Excuse me. So, having said that, because there are a lot of distractions here, sometimes it's noisy, sometimes there are a lot of different things going on at the same time. It's really difficult for me. It's not a good environment for creating a long, detailed instructional video. I mean, I can do it, but it's very difficult for me because this is not the right setting for making that type of a video. But I do what I can, and hopefully these little instructional videos will help you guys out. Okay? All right, let's take a look at some homework. Okay. Or actually, you know what I think here? I don't need to open this up because it's already opened. Okay, so let's go here. Now remember, guys, this is an asynchronous course. This is an asynchronous online course. That means we do not meet for regular lectures. We do not meet for regular lectures. In a class like this, people really have to work very independently. I make these videos for my students as a courtesy to try to point you in the right direction, but I'm under no obligation to make these videos for you. I do it because I think it's a good idea, and I think it will help. Excuse me. I think it will help some of you, or maybe most of you. But remember, guys, I'm really under no obligation to make these videos for you. I do this as a courtesy to my students. But in an asynchronous online course such as this one, it's really not required of the instructor. I'm doing this as a favor to you. Please remember that. Okay? Let me see. Okay, let's spend a little more time in chapter 2. Um, 3 students not started. Okay, not good. 7 students in progress and 9 students already submitted. Okay, so the students who haven't started yet, you really need to start. Okay, you really need to start it. So let's. Okay, student assignment view. Okay. The problems at the beginning are really very easy. So I'm going to visit some of the problems towards the end of the assignment. All right. So let's see. Okay. I'm just curious. I think. Um, um, okay, let's let's start with problem number 80. And for these problems, I want to show you guys some rackets. Okay, a little bit of racket programming. Terms of a sequence. Note, this is a multi-part question. Once an answer is submitted, you will be unable to return to this part. List the first 10 terms of each of these sequences. Do not enter commas for numbers greater than 1000. The sequence that begins with 2 and in which each successive term is 3 more than the preceding term. The first 10 terms are, so the sequence begins with 2. Okay, so let me go to Racket. So we're going to define a function. Define, what should I call it? Problem 80. The sequence that begins with 2 and in which each successive term is 3 more than the preceding term. Problem 80. And k represents an integer. K just represents an integer greater than or equal to 1. Okay. So if k is equal to 1, give me back 2. Otherwise, add 3 to problem 80, k minus 1. Okay, so this is a recursive definition. This is a recursive function definition. All right, so basically we're adding 3. So for example, here, let me, one moment. Okay. Okay, so basically, let's say, for example, I'm going to call this function problem 80. Oops, that's actually supposed to be one word. Problem 83. Is 3 equal to 1? No, it's not. So plus 3, problem 80, 3 minus 1 is 2. Is 2 equal to 1? No, it's not. So then I'm going to have, again, well, I wish I had a little more room here. Okay, plus 3. Okay. And that's going to be problem 80, this number minus 1, this number minus 1, so that's going to be 1. And we know what this is. This is the number 2. Actually, there should be parentheses there. This is 2. So we end up with actually plus 3 and 2, right? And what is 2 plus 3 plus 3? that is going to be equal to 8. So the first value is 2, and then 2 plus 3 is 5, and 5 plus 3 is 8. Okay. So let's see if that's true. Okay. Problem 81 is 2. Problem 82. Oh, no wonder. Oops. Okay, I'm missing parentheses here. There we go. Okay. Problem 81 is 2. Problem 82, 2 plus 3 is 5. Problem 83, 5 plus 3 is 8. Problem 84, 8 plus 3 is 11. Problem 85, can you guess what the next number in the sequence is going to be? 11 plus 3 is 14. And so on and so forth, okay? So it says here, I want the first 10 terms. For list, I'm going to make up a letter. It doesn't have to be K. It could be a different letter. Okay, I, range 1 to 11. Now this is important. 11 is not included in the range. So range, if I do, let me show you. If I were to do, oh, hold on a second. If I were to do range 110, this won't work. I'm going to get the integers from 1 to 9. I need to do range 111, and this will give me the integers from 1 up to and including 10. So if I were to do this, for list I, range 111, okay, problem 80I. So these are the numbers. These are the numbers in my sequence. Okay. In fact, we can define a new function, problem 80 sequence, K, for list I, range 1, 1 plus K, okay, problem 80I. Okay. So problem 80 sequence 10 gives me the integers 2, 5, 8, 11, 14, 17, 20, 23, 26, and 29. So that's pretty easy. 2, 5, 8, 11, 14, 17, 20, 23, 26, and of course 29. Pretty simple. It's not a big deal. It's not a big deal. Number 81. The sequence that lists each positive integer 3 times in an increasing order. So the first 10 terms are, well, that's really easy. 1, 1, 1, 2, 2, 2, 3, 3, 3, and 4. So here we have the sequence that lists the odd positive integers in an increasing order, listing each odd integer twice. Okay, so programming this in Racket might be a little bit tricky, but we can try it. So, but I mean, it's easy to figure this out by hand. So we're gonna have 1, 1, 3, 3, 5, 5, 7, 7, 9, and 9. So that's pretty simple. Okay, Chach, jump up. You can jump up. Jump up on the sofa. Jump. Okay, guys, I'm just talking to my dog, so don't worry about it. Okay, now programming this in Racket could be a little bit tricky, but we can give it a shot. Yeah, this actually shouldn't be too difficult. Let me see. So we have 1, 1, 3, 3, 5, 5, 7, 7, 9, and 9. So I'm thinking, there are a couple ways of doing this. Excuse me. We have a couple ways of doing this. We could actually, let me see something. Make list 3, 1. We have 3 1s. We can actually do this. We could actually, let me think for just a moment. Okay. So we have problem 82. Problem 82. And, excuse me, I think it's time for some lemonade. Okay, we have problem 82. K, well, this could be a little bit tricky. You know what I'm going to do? Problem 82 helper. This is going to be problem 82 helper. And here, I'm going to have an accumulator. And my accumulator, well, let me see here. My accumulator is initially going to be an empty list. It's going to be an empty list. And here, let me see. Actually, you know what? Yeah, okay. This can be K. Now, the problem with K, this is going to be tricky because, excuse me, K, here, for example, K is 10, which means I want the first 10 numbers in the sequence. But really, how many distinct numbers do I have? I have 1, 2, 3, 4, and 5 distinct numbers. So I'm wondering if, yeah, there might be, hold on one second. Let me see. There might be a better way of doing this. So if we do f of k, well, we need a starting value. We would need a starting value. Let's see, start, and we have k. Let me see. Define G. The next value, and that can be R. Okay, so this is definitely going to be a little bit tricky. So we are going to have cons. And by the way, if you're wondering what cons does, cons 1, 2, 3, 4, 5. That just puts a number at the front of a list. So we have cons, next, F. Let me see. We would have next, R minus 1. And the problem here I may need to, okay, hold on one second. So I think this might be better inside a let-rec binding. So here I would say, this might get a little complicated. So G is a function of lambda and then control backslash next in R. So if, yeah, you know what, I need to include this. If R is equal to 0, give me the empty list. Otherwise, cons next, F next, R minus 1. Okay. Okay. So G is a recursive function that's going to call R. And then you would have, it's going to, I'm sorry, G is a recursive function that's going to call F. F is going to call G, just as G is going to call F. All right. So then I could say, let me see one moment. If k is equal to 0, give me back the empty list. Otherwise, cons start, and that would be G start plus 2, and then k minus 1. Let me see. So if k is equal to 0, give me back an empty list. Otherwise, take this number here and cons it onto, well, actually this one, I'm going to make this one next plus 2, and this one we're going to keep start. Let's test it, because this function is a little weird. It's a little weird. Let me see. We're going to start with 1. Okay. There we go. So it does work. It actually does work. So this is a little complicated. There might be an easier way of doing this, but it's a little complicated, but it's actually kind of cool. So we're going to start with 1. What if I want 20 terms of the sequence? 1, 1, 3, 3, 5, 5, 7, 7, 9, 9, 11, 11, 13, 13, 15, 15, 17, 17, 19, 19. What if I want 19 terms of the sequence? This is, excuse me, this is the first 19 terms of the sequence. Okay, But here you can see that the problem requires the first 10 terms of the sequence. Okay, this is how you would define the first 10. This is how you would find the first 10 terms of the sequence. So this is called a mutually recursive function. This is a mutually hold on one second. This is a mutually recursive function. And the reason is because I have a function here called f. I have a function here called g. G calls f, and the function f calls g. They call each other, and the reason I did that is because I'm using the same value twice. 1 1 3 3 5 5 7 7 9 9 11 11 13 13 15 15 17 17 19 etc. etc. Okay. So this is a little bit of a complicated concept, but it's something you might want to use for your programming project. I mean, obviously, guys, you cannot copy this for your programming project. You cannot copy my work for your programming project. This is simply food for thought. This is something that could give you an idea, like maybe you'll do something similar. But I don't want you to do the exact same problem, and I don't want you to use the exact same code. All right? So here, remember, guys, I mean, you should be looking up this stuff on the internet. You should be reading a couple of books about Mathematica, Python, Racket. I just expect you to know how to define basic functions. You don't need to know a lot of advanced programming. You just need to know how to define basic functions. Like, for example, here, I'm always going to start with the number 1. I'm always going to start with the number 1, okay? So if that's the case, one second. There we go. What I could do, I could define a new function. Again, I'm going to use the word define. I could even call it g, because g at the top level does not conflict with this g. This is a local variable, basically. This is a local function. G is a local function that exists within f. So I really could have another function here called g. And g, and actually I'm not going to need parentheses here. G, I'm going to curry it, it's called currying, because the first value is always going to be the number 1. Always. Okay? It's always going to be the number 1. So instead of doing this, instead of doing this, I can just do this. Okay, so because it's kind of redundant if I do it this way. If I do it this way, I just keep repeating the first argument of 1 over and over and over again. Why bother, right? It's too much typing. It's a lot of extra typing. So what I could do is curry the function. Curry the function, which simply means that I am assuming that one of the variables, the first variable or the first 2 variables or the first 3 variables, whatever the case may be, always has a fixed value. It doesn't change. So, for example, here, the first variable always has the value of 1. So why worry about it? Why not just define a new function? Why not define a new function where the 1 is already automatically assumed? All right, and that's basically what I did. And you can do that using what's called the Curry function. The Curry function, okay? So it's actually kind of cool. Okay, Racket is an interesting language. It is really an interesting language. Okay, I love it. I think it's a really interesting language, and Racket is actually a variation of Lisp and Scheme. Racket is descended from Lisp and Scheme. These are older programming languages. Okay, Racket is descended from Lisp and Scheme. Lisp, Scheme, Racket, okay, they all have a similar syntax. So rather than, 2 plus 2, you would write, plus 2, 2. This is called prefix notation. Okay, because the operator comes before the operands. 2 and 2 are the operands. This is your operator, okay? It's actually kind of cool stuff, right? Okay. Can you do this in Python? Yes, you could. You could do this in Python. Could you do it in Mathematica? Yes, you could. Although in Mathematica, I think it's going to be a little bit more work. I think in Mathematica, it's definitely going to be a little bit more work. Okay. Excuse me. That was a big yawn. Okay. So here we have the sequence. This is number 83. The sequence whose nth term is n factorial minus 2 to the power n, where n is greater than or equal to 1. The first 10 terms are, okay, so first of all, we need, okay, the power function is already defined in Rackets. Okay, the power function is already defined in Racket. 2 to the power 3 is the same as 2 times 2 times 2, and that's going to be 8, right? 3 to the power 2 is the same as, 3 times 3, and that's going to be 9. Okay, so 7 to the power 5 is the same thing as 7 times 7 times 7 times 7 times 7, and that's going to be 16,807. All right, 2 to the power 8 is the same as 256 because 2 times 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 2 is 256, right? Okay, it's 2 to the power 8. So this is easy. However, the factorial function is not predefined in Racket. We have to define that. This is the factorial function. So we're going to have to define that, and that should be pretty easy to do. So again, I'm going to go up here in the definitions window. Excuse me. So this is the interactions window. This is the interactions window. This is the definitions window. And we're going to say we're going to define a new function. We're going to define the factorial function. Let's see. Cond is like if. It's like if. Very similar to if. If k. Do I need? Wait a minute now. Okay. If k is equal to 1. No, if k is equal to 0, just give me back 1. If k is equal to 1, give me back 1. Okay, else, you can use else or true. It doesn't matter. They mean the same thing, okay? You could use true or you could use else. They mean the same thing, okay? Then you would say factorial k minus 1. Oh, wait a second. Whoops. There we go. Okay. Let's see if it works. Factorial of 0 is 1. Factorial of 1 is 1. Factorial of 2 should be 2. Oh, wait a minute. No, what happened? Oh, of course. Of course, I forgot. Hold on. There we go. I forgot that part. There we go. Let's try this again. Factorial of 0 is 1. Factorial of 1 is 1. Factorial of 2 is 2, because it's 2 times 1. Factorial of 3 is 6, because it's 3 times 2 times 1. Factorial of 4 is 24, because that's 4 times 3 times 2 times 1. That's 24. Factorial of 5 is 120, because 1 times 2 times 3 times 4 times 5 is 120. Okay, and I think you guys get the general idea. You should get the general idea. Okay. So the function is n factorial minus 2 to the power n. And this is, let's see, this is problem 83. Problem 83. So define problem 83. Instead of k, I'll use n. It doesn't matter. Pick a variable name to represent the number, the number in the sequence. The index of the sequence that you're looking for, okay? And so here, this is really easy. This is simply going to be minus factorial n. Let's see, minus factorial n. And that's going to be 2 to the power of n. Okay, and we want the first first 10 terms. We want the first 10 terms. So I could actually use a traditional for loop. I could actually use a traditional for loop for this. So define problem 83 sequence. I prefer for list. I really do prefer for list, but you can also use a traditional for loop as well. Or actually, how would I do? Let me see for a moment. Okay, hold on one moment. Maybe I'll go ahead and use for list. But let me see if I can do this with a for loop or do loop. Hold on one second. So k result is going to start out being an empty list. And let me see. Index is going to start at 1. Okay. So then we would have, okay, so here, guys, I'm actually chaining together two different actions within the same block of code. That's why I'm using begin, because I'm chaining together two different it's called side effects, or side affecting, two different side affecting computations within the same block of code. So here I would have 4. Or I could even do, well, let me see here. Well, let me see. Okay, let me see if this is going to work. So for I, we could make this, maybe I should make this a start. Start for I, range start K, and let me see. Setbang is going to mutate the results. Setbang is going to mutate the results. So we're going to end up with problem 83. Oh, this should actually be k plus 1. K plus 1. Okay. Problem 83I onto the result. So I'm changing set bang. The exclamation mark is pronounced bang. Set bang changes the result. Okay. And then we're going to close the for loop. And if we keep consing, we're going to end up with the answer. The answer that we want will be backwards. We're going to have to reverse it. So then reverse the results. And actually, I'm not even sure if we really need this part. This part, you know what? We don't really need that. We don't really need that. That's extraneous. So, oops, there we go. Yeah. So let's see if that works. Okay, I'm pretty sure that's going to be the answer that they want. All right, so this is one way of doing it. I prefer for list. For list is great. For list is really great, but this is just showing you another way of doing it. So let me see if we can make that just a little bit smaller. Okay. Okay, so the first 10 terms are -1, -1, -2, -2, 8, 88, 656, 4,912, 40,064, 3,620. No, that's going to be, wait a second. 362,368. Let's see, 362,368. And this is going to be, wow, that's a big number. Let's see, 3,627,776. And that is correct. Okay, and that is correct. Number 84. Let's go up to 86, guys, and then we're going to end the video, okay? the sequence that begins with 3, where each succeeding term is twice the preceding term. So again, we can define this. Let's see. Define problem is at 84. Define problem 84. K. If k is equal to 1, or I can write it like that, give me 3. Otherwise, times 2. Problem 84, problem 84, k minus 1. Okay. So problem 84, 1, the first term is 3. 84, 2, the next term is 6. 84, 3, the next term should be 12, right? And then we have 24. And then we should have 48. And then we should have 96. Okay, you get the general idea. Now let's see if we can make this a sequence. Actually, let me see. Okay. Excuse me. There are different ways of doing this in Racket. So define problem 84 sequence. Let's see if we can do this. Let's define some local variables. Sequence is initially going to be empty. And index is initially going to be 1. If my index is greater than k, return the sequence. Here is the action. Here is the actual action. And the action that we want is we're mutating the sequence. Mutation, this is what mutation does, guys. Define name Mr. Douglas. Set bang name Mr. Lewitt. So I just changed name. The purpose of set bang, this is pronounced set bang. This is pronounced set bang. Okay? The purpose of set bang is to mutate variables. Okay, to assign new values to variables, to reassign variables that are already existing in memory. Okay, that's the purpose of it. Okay, so here we can do set bang sequence. Okay. Instead of consing, I'm just going to use append. So append, what does append do? 1, 2, 3, 4, 5. Okay. Append combines lists, 2 or more lists. Okay. So here we're going to have sequence, and then list problem 84 sequence index. Begin, okay. And then we need to, oh, you know what, 1 second. 1 second. I just want to see one thing really quickly, guys. Do I plus 1 when I is greater than 11, new line, display ln I. Oh no. This has to stop. Stop. Okay, that was bad. Okay, so run. Hold on 1 second. Let me. I may have to do this problem a different way. So hold on just 1 second. Hold on one moment. Oh, goodness gracious, what happened? Hold on 1 second. Okay. So, okay. Okay, so this is obviously not changing. Hold on one moment. If I is greater than 10, just print a new line. Otherwise, display ln I. No, this is the same thing as before. Ugh. Okay, why is it doing that? Very, very strange. Okay. But I think, you know what, we may not, okay, so actually it should be okay. Let me uncomment that. That should be okay. Index, add 1 index, which simply adds 1 to index. I could do this thing, I could do this. This is the exact same thing. Index. Okay, I'm not convinced this is going to work. Let me see. Problem 84 sequence 10. Okay, so it's not, yeah, this is not, oh, goodness gracious. Okay, so, yeah, so this is just going on and on and on forever and ever, which is so annoying. That's okay. We can do this problem a different way. We can actually do this problem a different way. So what I could do is define problem 84 sequence K. Okay. For list n in range 1, k plus 1, problem 84n. Okay, this makes a whole lot more sense. Problem 84, sequence 10. Okay, that's much better. Makes much more sense. Although we should be able to use a do loop. We should be able to use a do loop. So that's a little bit strange. It's a little bit strange, but that's okay. So that should be the answer to number 84. So we have 3 6, 12, 24, 48, 96, 192, 384, 768, and 1,536. And everything is correct. Although I should have been able to do this with a do loop. And that's a little bit weird, but that's okay. I'm kind of curious. Let me see. Do loop in Racket. I think this is the official documentation. Okay, so let me try that again. Hold on 1 second. So do, we're going to start with 1 plus 1. Let me just go back here to that example. Oh, it's I plus 1. Maybe that was my mistake. Okay, so this should be I plus 1. So then we would have, if I is greater than 10, just print a new line. Otherwise, display I. There we go. Or we could do escape P, and this should be ln. Okay, so the problem, okay, let's try to do this again using a do loop. Let's see if we can do this again. Let's see if we can do this with a do loop. Okay, so if we define problem 84, I'll just call it sec k, do, I starts at 1 and goes, well, this is how it's going to change, but we would need to start with an initial list. So sequence, and that's going to start, okay, how do we change sequence? Cons sequence, no, hold on 1 second. This would be problem 84I sequence. And we would have if I is greater than k, simply give me back the sequence. Actually, I think this is going to be in reverse order, so give me back the sequence, but I'm not sure if this is going to work. Problem 84 sec 10. That actually did work beautifully. That's really interesting. That is really, really interesting. So this is a do loop in Racket. Okay. So here I'm defining my variables. I have a counter. I is my counter. I is my counter. I have a sequence that actually stores the results. This actually stores the results. And this explains how these variables are going to be changing. So actually, that's really interesting. You know what? I could call this, instead of sequence, I could even call it result. And this would just be, of course, I have to call this result. And then this has to be called result. Okay. And this number k has to be greater than or equal to 1. K has to be greater than or equal to 1. Okay. So problem 84 sec 20. Okay, actually I should, okay, let me do it like that. So problem 84 sec 10, which is the problem from the book, we start with 3. 6 is 2 times 3. 12, 6 is 2 times 3. 12 is 2 times 6. 24 is 2 times 12. 48 is 2 times 24. 96 is 2 times 48. You get the idea. Every number in the sequence, starting with 3, starting with the initial value of 3, every successive term of the sequence is twice as large as the preceding term. Okay, that makes a lot of sense. And this is a do loop in Racket. Although personally, I do prefer for list. Okay. Okay. Okay, so number 85, and then we're going to conclude with number 86, guys. And that's going to be, that's going to be it. So 85 and 86. So the sequence whose first term is 2, second term is 4, and each succeeding term is the sum of the 2 preceding terms. Okay, so this is really a Fibonacci sequence. Right? So here we have define Fibonacci, and we're going to have first value and second value. And here we're going to have the number of values that we actually want. That's the number of values that we actually want. All right? So this time I'm going to just do it all with one function. I'm going to use the function for generating the values is going to be the same function that I use for generating the sequence of values. So if k is equal to 0, then simply give me the empty list. So remember, guys, here, Fibonacci, I'm using the function that I'm using to generate the values is the same function that I'm going to be using to generate the sequence of values, which is now what I did up here with the other problems. That's not what I did here with the other problems, okay? So here we're going to do, let's see. Well, actually, hold on just one second. Yeah, that should be okay. So here we're going to do cons. Let me see. Hold on one second. The first value and then Fibonacci. The second value takes the place of the first value. And then we're going to add those two values together. First value and second value. Okay. And then k is reduced by 1. Okay, let's see if this gives me what I want. Fibonacci 2 and 4, 10. 2 plus 4 is 6, and 4 plus 6 is 10, and 6 plus 10 is 16. 10 plus 16 is 26. And then 26 plus 16, which is the same thing as 26 plus 14 plus 2 is 42. Yeah, this works. This is beautiful. This works beautifully. So here we have our answer. We have our answer. So the first 10 terms are going to be 2, 4, 6, 10, 16, 26, 42, 68, 110, 178. And that is correct. Okay, this is going to be our last problem, guys. This is going to be the last problem. Okay. So number 86, this is the last problem for this video. This is not the last problem for your homework. It's the last problem for the video. The sequence whose nth term is the number of bits in the binary expansion of the number n, where the number n ranges from 1 to 10. So let's define this. Define decimal to binary. Oh, sorry, accumulator, and this is the number. It's a positive integer greater than or equal to 1. If k is less than, well, you could say if 0 is greater than or equal to k, the algorithm is finished. Return the accumulator. So if 0 is greater than or equal to this value k, which is initially a positive integer, you're done with the algorithm. The algorithm is finished. Okay. Otherwise, I'm going to declare some local variables. K divided by 2 is the quotient of k2. And then k mod 2 is going to be modulo k2. Cons k mod 2 decimal to binary. Oh, here, I'm using an accumulator, so I could just do this. Decimal to binary cons k mod 2 accumulator k div 2. So then we're going to have decimal to binary 1. Oh, oops. Decimal to binary, I need my accumulator 1. That's just 1. Decimal to binary 3. I keep forgetting to do that. I need my accumulator. Decimal to binary 3. Look at what this error message says. Decimal to binary arity mismatch. Arity refers to the number of arguments that a function requires. The expected number of arguments does not match the given number. Expected 2 arguments, given only 1 argument. So I'm missing an argument, okay? So how do we read this? How do we read this? Excuse me. So these are the bits, right? These are the bits in my list. Okay. These are the 2s, these are the 1s. How many 2s do I have? I have 1, 1, 2. And how many 1s do I have? I have 1, 1. So how many 2's do I have? I have 1, 1, 2, and I have 1, 1. 1 times 2 plus 1 times 1 is equal to 2 plus 1, which is equal to 3. So the decimal, the binary representation, of the decimal integer 3 is going to be 1, 1. Okay, I hope that makes sense. Okay, what about decimal to binary 4? Same idea. Okay, so this is working pretty well. Again, the first argument is always going to be the empty list. So here I could define a new function, define deci to bin, and if I'm curring, I don't need the parentheses, here around this value. So curry decimal to binary. And this creates a curried function. So deci to bin is the curried version of decimal to binary. Okay. And then here, let's run that. Okay. Deci to bin 10. And let's see if that's true. So 1, 0, 1, 0. These are my 1s, these are my 2s, these are my 4s, these are my 8s. So 1 times 8 plus 1 times 2, whoopsie, is equal to 8 plus 2, which we know is equal to 10. Sorry, this is equal to 10. This looks like 16 or something. Okay. So now we need the length. So what I could do very simply is for list I, oh, wait a second, sorry, or k, it really doesn't make a difference. Range 1 to 10. And we need the length of those bits, the length of those binary representations of the decimal numbers. So length deci to bin k. And there you have it. There you have it. So the first 10 terms are 1, 2, 2, 3, 3, 3. And then let's see, we have 1, 2, 3, 4. We have 4 3s. And then we have 4, 4, and 4. And that looks great. Okay, so guys, I understand you can do, the problems that I just did. Can you do them with a regular calculator? Of course you can. You could probably even do them. Well, I don't know about pencil and paper. I think you would need at least a calculator. However, the bottom line is, guys, nowadays a lot of people, have to know something about programming, and that's even true of non-programmers. I mean, there are people out there who, they do not call themselves programmers. They do not identify themselves as programmers. And yet, their jobs do require some knowledge of this technology. They have to have some programming skills. They have to know a little bit about recursion. They have to know how to do, how to implement a for loop, or how to execute a for loop, how to execute a do loop or a while loop, or how to define a function, or how to do a query or a search, how to search through an array, how to search through a list, how to search through a binary tree, how to search through a database. I mean, these are basic skills that many professionals need, even if they are not, working as professional programmers or software developers or software engineers. So that's why, guys, I really feel that, you really should learn something about how to use a programming language to solve basic math problems. And remember, a lot of discrete math is actually used in computer science. Excuse me, guys, I do have a sore throat today. Sorry about that. 1 second. A little lemonade. Okay, so a lot of the ideas from discrete math, a lot of the proofs, a lot of the functions, a lot of the formulas, a lot of the concepts from discrete math, they are used directly in computer science. And the vast majority of students who take this course are actually moving on to take more courses in a computer science major, a computer engineering major, or a cybersecurity major, or an information technology major, or something like that. So these are skills that are really good to have. If you really don't like Racket, you can use Mathematica and Python for your programming projects. But I encourage you to learn a little bit about Racket because it is really a new way of thinking about programming. At least it's new for most of you, okay? So if you have questions, email me. But please, guys, be specific about your questions. Don't just email me and say, Mr. Lewitt, I need help. What do you need help with? Which problems? Which questions? Is there something in Racket that you don't understand? Is there something in Mathematica you don't understand? Is there something in Python you don't understand? Don't just tell me you need help. You have to be very specific about what you need help with. All right? So, okay, guys, that's going to be it for now. And we will communicate at some point in the future, okay? In the near future. And yeah, this video is more than an hour. Okay, got to be a little bit longer than anticipated, but that's okay. All right, guys, take care and enjoy the rest of your week. Enjoy your weekend, enjoy the rest of the week, and we will communicate very soon, okay? Bye-bye.